Folding and faulting questions, video 1. Now remember, when we're confronted with these sort of questions, don't rush straight into the answers. Look at the map itself to start with. For instance, we can see there's a clear fault here. We can see there's an axial plane trace. Okay, we can see that has been displaced. We can see a metamorphic intrusion, metamorphic aureole here. We can see an intrusion there made of granite. And don't forget as well the information, the written information at the top. Sandstone is the youngest sedimentary rock shown on the map. So if we have an axial plane trace, we know it's some sort of anticline or syncline. With the youngest bed in the middle, we should know that would be a syncline. Let's have a look at the questions. What feature is formed between X and Y? As we just said, there's an axial plane trace there. Sandstone being the youngest bed, that would make it a syncline. Remember this diagram to show you the formation of a syncline and how the youngest beds are found at the core in the middle of the syncline. Draw arrows in the empty boxes in figure 1 to show the direction of the beds at location X and Y, so the dip directions. Again, it's a syncline, so those should point towards the axial plane trace. Next question. What type of fault is shown on the map? Well, here's our fault. You can see it nice and clearly. The first thing to notice is that the sandstone beds which have been displaced by the fault are of equal width. That normally makes it a strike-slip fault. The second point, as we said before, the axial plane trace has been displaced, as you can see here, by the fault. So therefore, it would be a strike-slip fault, as you can see in this diagram. Further, we can add what type of strike-slip fault it is. Look at this diagram here. You can see as the dextral fault says that when you stand facing the fault, if there's movement to the right, then that will make it a dextral fault. As you can see here, there is movement to the right in that direction if you're standing in this way, so that would be a dextral strike-slip fault. Did the fault or intrusion happen first? Again, here's our fault. Remember what we said about cross-cutting relationships. Here, I've marked in red the edge of the aureole and also the edge of the metamorphic aureole. The granite intrusion has cut across the fault and the aureole hasn't been displaced. The law of cross-cutting suggests, therefore, that faulting happened with the oldest part and the intrusion second as it's cut across the fault. The diagram below shows a fold cut by two faults and a dike. Give yourself a couple of seconds to look through this map, familiarise yourself with it. Okay, what type of fold structure is shown on the map? Well, we can see our dip arrows here, clearly pointing in towards the axial plane trace here. It's the same all the way along. We can see these dip arrows, and the dip arrows are pointing towards the axial plane, therefore it would be a syncline. Is fault 1 a strike-slip or dip-slip fault? Well, here's fault 1. Okay, we can see the axial plane trace is not displaced by the fault, so therefore it would be a dip-slip. One side has moved up and one side has moved down. There's the axial plane trace, hasn't been displaced in that fault. Is fault 2 a strike-slip or dip-slip fault? Marked in green is fault 2 there. You can see this instance that it has been displaced. The axial plane trace in brown has been displaced by fault 2. So therefore that would make it a strike-slip fault. Notice as well the width of the beds on both sides of the fault are roughly the same, indicating again that it's a strike-slip fault. Finally, simple question, what trend does the axial plane trace have? You can see it starts from a northwest direction to a southeast direction. So the trend is northwest, southeast. A common question again about relative dating or the relative order of events in which they happen. So which of fault 1, fault 2 and rock A are the eldest? Well, it's about cross-cutting relationships. There's fault 1, there's fault 2, and there's rock A. Now, fault 1 has been cut across by rock A and also cut across by fault 2, so therefore it is the oldest. Now, between fault 2 and rock A, you can clearly see that rock A has been cut by fault 2 here, so therefore that would make rock A the middlest and fault 2 the youngest. Now this is a specimen question from 2017. Again, familiarise yourself with the map. What can we see? Well, there's quite a few things we can look at here. We can see there's an axial plane trace there, looking at the symmetry of the outcrop of rocks. Oh yeah, that's been slightly displaced, so that could make F2 a strike-slip fault. Looking at that, looking at the width of the beds as well, it seems very likely that it will be. Also, fault F2 is vertical, that's a clear indication. We've got some dip arrows here as well, pointing inwards, probably making it a syncline. Fault F1, very low angle fault, perhaps that's going to be a thrust fault, it's so young. Looking as well, the youngest and the oldest. The youngest is this striped one, which is in the core, which would indicate again that it's a syncline that certainly hasn't been overturned. Okay, let's look at the questions. Now this is a very common question again when they're asking you to sort of tick two statements. It's a question of process of elimination. Right, what we know so far, we know that the fold is a syncline. So we can put an X by the fold as an anticline and the fold is a syncline. Again, we looked at these arrows here pointing inwards towards the axial plane traced there. And we also know from a syncline that the youngest beds are in the center, and that would support that statement. Okay, next question. The fold has limbs of equal dips. Why can we put an X there? Well, look at the width of the beds. This one to the north, this one to the south. The same rock, but they're vastly different in their outcrop width. Again, do you remember this diagram from the previous slides? You can see here that there's a dipping syncline. When we have a steep part of it, it causes a very small outcrop, but when it's much gentler, we have a much wider outcrop, even though it's the same width. So that's why we can put an X by the fold as limbs of equal dips. The fold is younger than the faults. Well, clearly here, this fault has cut across that fold, so we can put an X by that statement. The fold has been overturned. We know that's not true because we can see the dip arrows there indicating it's a syncline, but if the older beds are in the middle, then it would have been overturned. However, we can see, as expected, the younger beds, or the youngest beds, are in the center, so therefore the fold hasn't been overturned. Now, by a process of elimination, it means that the last one has to be tick. The northern limb of the fold dips at less than 60 degrees. Well, we know that's going to be less than 60 degrees because this part here is 60 degrees and it's a narrower outcrop. This is a much wider outcrop, indicating it's more gentle than 60 degrees. Fault F1 is a dip-slip fault with a downthrow to the east. State one piece of evidence on the map that confirms F1 is a dip-slip fault. Well, nice and clearly we have the axial plane running straight through the centre of that fold there. Therefore, we know it hasn't been displaced, making it a dip-slip fault, i.e. one side has moved up and one side has moved down. Fault F1 is a thrust fault. What evidence of the map supports this? So remember, a thrust fault is a type of reverse fault, which itself is a type of a dip-slip fault. Again, we mentioned at the start, it's 18 degrees, it's very low angle, that makes it likely to be a thrust fault. Fault F2 is a strike-slip fault. State two pieces of evidence on the map which supports this statement. Well, we can see the axial plane trace has been displaced from there to there. That's a clear indicator. And also, as we said, the beds on either side are pretty similar in width. Again, indicating that there's been horizontal movement but no vertical movement. We could also say, as we stand here, that the movement has been to the right, making it a dextral strike-slip fault.